Good morning. Today's topic is combining like terms. I'm going to walk through definition, real-life example, and then talk about what it looks like in our math problems today. So first off, what does it mean to combine like terms? It means that we can add or subtract terms that are like terms. And like means that they have the same exact variable and the same exact exponent. That was part of yesterday's vocabulary video. All right, so here's a real-life example. Let's say that you're at the grocery store, and your mom or grandma or someone whoever you're there with sends you over to the fruit section and says, hey, grab what you want. And you and your brother run over there, but you don't want to share, so you each get your own stuff. And you grab 4 oranges and 2 apples. And your little brother, he only likes oranges, so he grabs 3 oranges. So when you get up to the register, how are they going to ring those up? Are they going to ring them up all together as one thing? So adding the 4 plus 2 plus 3. So you have 9 orange apples. Is that a thing? Orangeables? Or no, that doesn't make any sense. Do you have 9 apple oranges? That's not really. You don't have 9 of anything. You have 9 fruits. But what you really have are 4 oranges and 3 oranges. You really have 7 total oranges. But you've also got these 2 apples out here that you wanted. So you've also got plus 2 apples. So the idea is that we can put together things that match, but only things that match. If things don't match, like apples and oranges, then we don't get to mix them together. But we do get to mix together the things that are matches. And all we mix together are the counts. We didn't change the oranges. Your 4 oranges and your brother's 3 oranges makes 7 oranges. Not oranges to the second power or anything like that. We don't change what we're counting. We're just how many. All right, so let's take a look at how that would look in algebra. So in this first one, 4x plus 5x. So think about x as like an apple or an orange. If you got 4 apples and I got 5 apples, all together we have 9 apples. 9x. Not 9x squared. So no exponent, that's just it. We only add or subtract the coefficient. We do not add or subtract the actual x's or anything like that. We're just finding things that match, and we want to know how many of them. You got 4 x's, I got 5 x's, together we got 9 x's. All right, now the next one. These terms, again, remember the terms start and stop with the plus and minus sign. There are 2 of them in this one. And one is negative, one is positive. And they both have the letter y. So they're like terms. So the like term part, the y, doesn't change. What does change are the numbers with it. Negative 6 plus 2 makes negative 4. It's a little bit like back in elementary school or middle school when you had to do things like add fractions. Like let's say you had the fraction 3/5 plus 2/5. Well, the part that matches in fractions, the bottom, the 5, it doesn't change. That's the same thing that just happened with the y. The part that needed to match, the y, didn't change. We kept it the same. Same way with adding fractions. Then we did do is we would add the actual numerators. We'd add those numbers. All right, so that's what we did here. We actually added the numbers that went out front, negative 6 plus 2. All right, so that's the idea. All right, number 3, a little bit of a tricky one. All right, so our letters, first our terms. We have a negative 2x and a negative 1x. Now they are like terms. They both have the same letter, x. Same exponent. They don't have 1. That's a match. So that means the x, just like back here with the fraction, that part won't change. Right? What does change is the numbers in front. And it's negative 2, and then you don't see it, but that's a 1 right there. If you don't see a letter or number in front of a letter, it's always a missing 1. We just don't write it. All right, for the same reason that if somebody says, hey, how old are you? And you say you're 14, you don't say that you're 1 times 14. Well, that's pointless and silly. You just say 14. All right, same thing here. You don't say 1 times x. We just say x. All right, so when I take negative 2 and then minus 1, that'll get me a negative 3. And if that's the part you stink at, use the calculator. You've got one. You can use it anytime you want. All right, number 4. This one's a little bit trickier. In this one, my first term is positive 6y. Remember, if there's no number or no sign in front, it's a positive. Then the plus sign starts my next one, so my next one is positive 3x. And my next term starts with the plus sign and ends when it gets to the next one. So positive 2y is term number 3. And then my last term is positive 5x. All right, so I'm allowed to put together the ones that match. And the first thing I see is this one with a y in it right here. Are there any other matches? Well, yes, there are. There's a match back here. I can put those two together because they match. 6, skip over this 3x part, and then plus 2y. So 6y plus 2y, well, the y would stay the same, and 6 plus 2 makes 8. Now I'm going to look at the other part, the other letter. There's an x here, positive 3x, and another matching x there. I'm going to put those together. There's a matching x, and their numbers would be positive 3 and positive 5. When I add them, I get positive 8. Now I want you to notice something here. I want you to notice that with the green one, the 8x, I wrote the plus sign in front. But with the red one, the 8y, I did not. And the reason why is because you don't have to write positive at the start of a math sentence. But you do have to write positive in the middle. So that's why I put the plus with the 8x, and I didn't write a plus sign in front of the 8y. Now if I had put the plus sign in front of it, there's nothing wrong with that. It just doesn't look right. It looks kind of weird. So again, we don't write the plus sign at the beginning of the math sentence, but we have to at the end. All right, last one. Negative 3x squared plus 7 minus 4x squared. So the first thing I see, again, where are my terms? My first term is negative 3x squared. It stops when it gets to the next plus or minus sign. My next term is just the plain constant, positive 7. No letters attached to that one. Stops because we got to another minus sign. And then my last term, negative 4x to the second power. So again, I'm looking for things that match. And I got an x to the second power here, and an x to the second power there. I'm going to put them together. Since I'm adding and subtracting, I am not going to be changing any exponents. I am just going to copy the x squared part. Then I'm going to put together their numbers. The number negative 3 together with the number negative 4. So negative 3 minus 4, or negative 3 and negative 4, makes negative 7. And again, if that's the part you struggle with, use a calculator. Right, and the last part, this plus 7. It's called a constant. It is only like terms with other constants. And again, a constant is a number that does not have a letter. So that 7 is the only constant in the problem, so I'm just going to recopy it. Plus 7. This is what your work looks like today. So I'm expecting potentially having some issues with it. It's not always easy at first. So if you're stuck on something, let me know. If you're at home, send me a message. I'll answer it. All right, good luck.